We present GazeRayCursor, a novel technique for 3D object selection that enhances controller raycasting by leveraging gaze for object depth estimation. Raycasting is a common technique for pointing and selection tasks in virtual reality, but selecting objects through raycasting can be ambiguous when the ray intersects multiple objects at different depth. This is especially evident when using only a single controller ray or a single gaze ray for selection. Using the convergence of the left and right gaze rays can help to reduce ambiguity, but it could still lead to inaccuracies because the eyes are very close together, which means the two gaze rays can be close to parallel. We propose a method to combine the gaze and controller rays to infer the depth of an object, which could help resolve ambiguities in target selection. The method calculates the projected intersection, which is the point on a controller ray that is closest in distance to a gaze ray. We use the position of this intersection point to estimate the depth of the object. We carried out a point and select experiment in VR. In each trial, a target sphere was rendered at a different depth, size, and angle. The task was to select the target by intersecting the controller ray with the target while focusing gaze directly on or near the target. We then used the controller and gaze data collected from the experiment to test out 4 different combinations of left gaze ray, right gaze ray, and controller ray that could be used to infer object depth through the projected intersection. The results showed that using an averaged left and right gaze ray together with the controller ray achieved the lowest depth estimation error overall and performed significantly better than using gaze convergence. Based on this depth estimation method, we designed our selection technique GazeRayCursor. In a comparative study, we evaluated 2 variations of GazeRayCursor, the GazeRayCursor Auto and GazeRayCursor Semi, against RayCursor, which is an existing selection technique from the literature. We describe each technique in more details. In RayCursor, the default behavior is raycasting. When the controller ray intersects one or more objects, the intersected object that is closest to the user is highlighted. This technique also supports a manual adjustment mode. The user can manually adjust the position of the cursor along the controller ray using the controller touchpad. In GazeRayCursor Auto, gaze is used in combination with the controller ray to disambiguate between objects. Recall that we calculate the projected intersection between the gaze and controller rays to infer object depth. So when the controller ray intersects one or more objects, the object with the hit point closest to the projected intersection is highlighted. For each object that the controller ray passes through, a red flashing circle is shown at the hit point to help focus gaze on the object. For GazeRayCursor Semi, by default it behaves exactly like GazeRayCursor Auto. However, the user can manually adjust the position of the cursor using the controller touchpad in the same way as the menu mode in RayCursor. We evaluated GazeRayCursor Semi to determine how often participants would use the menu mode to disambiguate between objects. We designed a target selection experiment with a dense number of distractor objects in the environment to maximize the need for disambiguation between objects. The analysis demonstrated that both GazeRayCursor Auto and GazeRayCursor Semi achieved significantly faster selection times compared to RayCursor, and GazeRayCursor Semi reduced menu depth adjustments by 10-fold. Please see our paper for more details.